Okay. So, last class we are discussing about the different synthesis technique. So, if you see that in these slides, the different kind of synthesis techniques are there: articulatory synthesis, parametric synthesis and quantitative synthesis. So, based on the technique, three types: articulatory synthesis, parametric synthesis and quantitative synthesis. So, if you see the articulatory synthesis is the if you remember the tube modeling class. So, what we try to develop is the mathematical model of the human articulator. So, if I able to mathematically model the human articulator, then if I excite that articulator by a excitation which is called vocal cords, and then I can generate the speech signal. But what is the complexity in articulatory modeling? The complexity is that if I develop that model, some model parameters, or you can say the model is changing with respect to time, it is not continuous. If I say Kolkata, model is not same for all west. So, once against the time the models are changing, that means constriction area will be changed, airflow dynamics will be changed. So, if we all change, the model composition is changing. So, this means that I require lot of mathematically, you can, that is the super model that which can take this kind of variation, so that I can generate the articulatory speech. But it is very good things that if I am able to generate this, I will mathematically model this thing with respect to time, and then I can excite that model by either a impulse or a noise to generate the speech. So, that is called articulatory synthesis. So, a lot of research is going on in articulatory synthesis, because it not only provide me the speech synthesis, also I can simulate the human vocal tract also. If I able to construct mathematically, or I can say that instead of this, if I able to make a some instrument which can simulate this thing, is fantastic. So, that people are doing this articulatory modeling, lot of research is going on in articulatory modeling, but this is a very tough, because with respect to time, suppose I calculate the cross sectional area for O one frame, next frame the composition will be changed. So, mathematical model is changed. So, those kind of heavily computational complex problem is there, but research is going on, that is called articulatory synthesis. Then there is a parametric synthesis. If you remember, we said in that a speech event, or I can say whether it is O or whether it is A, it can be determined by the formant frequency. If you remember the formant frequency F1, F2, F3 and formant bandwidth, if I know the formant frequency and formant bandwidth, I can generate O. Okay. So, that is called parametric synthesis. So, if I know the formant parameter and formant bandwidth for that particular speech event, I can generate the speech event using articulatory synthesis. That you know the LPC model. If I know the LPC feature vector A1, A2, LP, then I know designing a filter, I can generate that event. But the problem is that if you see that once we speak, the movement of the speech formant is dynamic, it is not static, that this frame it is x, this frame it is y, it is continuously moving. So, speech formants are moving continuously. So, co-articulatory effect, while it is moving from one phoneme to another phoneme, how the formant is moving is very important. So, that formant dynamics I have to know. So, that formant dynamics if I able to apply, then I can generate the speech using this kind of parameter. That is why it is called parametric synthesis. So, formant synthesis is called parametric synthesis. It is developed based on set of parallel filter, because nothing, if I know the formant frequency, I can design that filter, and based on the gain of that formant I can pass the impulse response to particular formant and can generate that speech signal. So, that is called formant synthesis. Then there is a HMM synthesis. Using vocoder, we develop that HMM based speech synthesis, which I will details I will talk at the end HMM or which is called HTS. Recently mostly used TTS system is HTS, hidden Markov toolkit based speech synthesis model. This is mostly used TTS engine currently. Then there is a concatenative synthesis, which is you can say that before HMM based TTS is come, this concatenative synthesis was that highestly used synthesis technique. That initially it was developed diphone based synthesis, then we have developed one synthesis technique called element based synthesis technique, and during my during my 2000 I think 3 to 2008 I was in CDAC. So, that time we developed that Yesnola, this is called if you know Professor Datta, A.K. Datta, myself, we are developing that Yesnola techniques with speech synthesis, which is nothing but an element. We use the speech element as a unit, and that time the diphone based synthesis was there. Then there is a called unit selection, then unit selection with prosody modification, and last one is HMM based synthesis also. It is two types, the one is called HTS, one is parametric, another is non-parametric. Only the choice of the segments are detected by the HMM model. So, that is HMM based speech synthesis, which is also used in concatenative synthesis. Okay. So, now I have not discussed about this thing, already discussed. Forward synthesis does not use any human speech sample at runtime, instead of it puts synthesis speech as a create using acoustic model. Parameters such as frequency, amplitude, etc., are varied over time to create a waveform of articulatory speech. Then concatenative synthesis, it is a very simple modes of speech synthesis technique. So, what it is required? Any concatenative synthesis is required a pre-recorded database. If I say the machine, machine acts as a female voice. So, I required a pre-recorded female database. If I record it, pre-recorded database, then for the text which has the input, I can generate that text speech from that pre-recorded database. Very simple example will come from that concatenative synthesis. You can understand that if you go to the train station, there is a lot of announcement. If you see that IVRS, that the train will come at platform number 2, train come on platform number 7. If you say that kind of announcement happening. Now, if you minutely notice, if some station had added one platform extra after certain time, after 10 years, there is a IVRS systems available in that station, but after 10 years there is another platform is added. So, let that is platform number 5. So, the recorded voice after 10 years same voice is not available. So, they are recorded from different speaker platform number 5. So, you find that the train is coming on will be one voice, platform number 5 will be other voice. So, what is there? So, they have a pre-recorded speech for all information, and depending on the train coming, and so they are adding some unit. So, there is a pre-recorded unit, maybe train number, station number, platform number, train name, all are pre-recorded in the database. So, depending on that which train is coming, they search it and add it together and play it. So, that is nothing but a concatenative synthesis. So, instead of word, so if I say that it is very easy, because if the number of trains are very less, the number of or you can say the finite, number of platform are also finite. So, I can record the finite number of words. But think about the language. I have an infinite language words, and they can combine in any way. So, how do I record it all speech? It is very tough to record all those things. And also if I record it, then matching is very tough, because the some part of sentence will be same some other way, next part will be sentence speaking some other way. So, all kinds of problem will be generated. So, what will they said, instead of recording word, sentence, all kind of things, initially they thought if I record only the diphone. So, for a particular language, if I have a that phoneme, how many phonemes are there in English? how many phonemes are. So, for Bengali, suppose there is a 33 consonant and there is a 7 vowel, and I can generate how many diphones will be there, I can generate how many possible diphone will be there. So, what is diphone? Diphone is basically, if you see, diphone is defined like the midphone is suitable than the edge. It is said the mid of the phone is suitable for the edge. So, that is why it is called diphone, both the phone. So, how it is recorded? Now, if you remember, or I can show you in here, suppose I open an waveform in here, let us hit this is the waveform. If you say that if I cut the waveform in here, there may be some erroneous result will come. If you remember, I said the steady state vowels are more likely same. If I zoom this portion, if you see the vowel period are look like same. So, if I cut it here in one of the epoch position of the every vowels, one vowels, then from here to middle of this to middle of this, then I can say it is a diphone, and when I added them different diphone, the error will be minimum. So, because the steady state is nothing but a steady portion of the vocalic region, because there is no dynamics are there, I cannot say which one is so, because it may be the pure consonant, but consonant to vowel transition is important. So, that part also contain the consonant information. So, I cannot select the transitory part, I can select the steady state part. So, steady state part to steady state part I can cut, I can make a dictionary. So, all possible diphone for a particular language, I cut steady state middle part of the steady state to next middle part of the steady state, and I prepared a dictionary, signal dictionary, which contained all the diphone. Now, if you see, any text will come, any sentence or any text will come, that is consist of some combination of those diphone. So, I can pick up those diphone and add it together to combine them, and I produce the speech. That is called diphone synthesis technique. Diphone synthesis technique. So, why I cut in the middle? Because that part is the steady state vowel. I cannot cut here, because there is a transitory portion which is part of the saw also. So, that is why I take the diphone middle to middle, that is why it is called diphone. So, this diphone database. So, training, choose unit. So, what is required? I have to record it all diphone. So, I can say put a, ba, a. So, how do I record them? I cannot record a single diphone by pronunciation. So, I can say I can generate some nonsense words which contain all the diphones, and I pronounce that words, and I can cut those that the diphone from that word signal. Okay. Now, or I can record the natural speech, and I collect the, or I can see I have a large text corpus is there. I can analyze that text corpus to find out how many sentences is required to cover all the diphones which I required. I can search in the corpus, I can find out the sentences and take that sentences and recorded that sentences and cut the diphone from that recording. But the problem is that if it is natural sentences, then every sentence has its own prosody, depend on its, you can say, the structure of that sentence. So, if I cut a diphone from the beginning of the sentence and the same diphone if I cut from the end of the sentence, two diphone will be different, because of prosody is changing. So, if I do not want that prosody is not required when I just simply synthesize the segmental information, then I can say okay, I discard the prosody, I recorded the word with a carrier sentence which is a neutral carrier sentence, and then I can cut the signal from that nonsense words. So, that is called diphone synthesis. Okay. Now, if you see all kinds of diphone advantage, then the disadvantage making recording consistent, diphone should come from mid words, not take the beginning words, because beginning word voice is started. So, beginning word I do not want, I want mid of a word, that diphone should be taken. Then that same times we are also developing one technique which is called Yes-Nola epoch synchronous non overlapping add method based TTS, which is the text analysis, all those are same, only what we want, we instead of diphone we call it is a part name. So, I am not explaining the prosody part, I am only explaining the signal part, which is called part name dictionary. What is part name content? If you see, okay, I can go to here. If this is the recording of a consonant, vowel and consonant signal, like ka, 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 kha, 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 I recorded, and if it is a ka, you know this is occlusion period, this is burst, this is BOT and this is transitory part. So, I can say after burst to the steady state vowel is important, because that is the dynamics part of the signal. So, I can say it is consonant to vowel transitory part, CV segment. Then I can say up to burst, beginning of the occlusion period to the end of the burst, I can say it is a consonant. Then that is steady state vowel, then again from steady state vowel to consonant transitory part. So, my dictionary content only C, CV, V may content or V may not required also, I can generate this V portion depending on the duration, I will come later on that, then BC and then C. So, for all the consonant and vowel, I generate those C, CV, V, BC, those kind of signal. Then suppose I want to produce Bharat. So, it is nothing but a consonant Bha, which is occlusion past burst, then Bha to R transitory part Bha, then steady state A vowel part, then R to Rho transitory part, then Rho is a simple consonant part, then Rho to R transitory part, steady state vowel, then Rho to To transitory part, then To. I can generate Bharat. Any word will come, I can divide those words like that way and I can generate. So, here is a Hindi is there. So, bhajan, bha to O transitory part, O to zo, then zo consonant, jo, o, then o, no, bhajan it will be pronounced. So, the synthesis rule is simple, CVC, if you see I can generate C, CB, B, BC, C, B and fade out of BO means fade out. So, if you see the bhajan, bhaze is there, then BCB, if the segment is BCB, then I can generate like this way, if it is CBYB, I can generate like this way. So, those rules are the synthesized part. Okay. So, this is called Yes-Nola based synthesis technique. I can show you the quality for Bangla.
রাজা মহানন্দ রাজধানীতে তৈরি করেছিল শিব মন্দির ও বৈষ্ণবদের মন্দির.
So, prosody is not there. If you see it is a flat, I can say it is only all part names I have collected and all part names are concatenated together to produce the whole sentences. Now, if you say, I told you the steady state vowel, no. So, if you see the steady state vowel, if I show you in signal, if you see the steady state vowel, see the vowel periods are almost identical. If I say if this is the beginning of the vowel period, then up to here is one vowel period. This is called epoch, the beginning of the glottal impulse. If you analyze, it will come in here. So, here to here is a vowel period. So, if I suppose the steady state vowel, I do not know how much long is required. So, depending on the duration requirement, I can repeat this vowel portion to generate this. I can show you here also. Suppose if I cut this vowel, I do not know whether you are able to listen it. It is audible. I can select the device. I think device has to be loaded. Okay. So, if you are able to listen it, I think you are not able to listen it. I will see that what kind of device it is there. Okay.
মশার জন্মের পর মশার জন্মের পর
So, that is a sentence. Now, if you see steady state vowel, I want to increase the vowel duration in steady state. So, if I say this is the steady state beginning and up to here all are look like same. Okay. So, I cut it here, I will show you. So, this is the one period of the vowel, up to here is one period. Then I can copy it, then I paste it here again, then I can again paste it here, I can again paste it here, I can again paste it here. If you see, the vowel length is increases,
ঠাট ঠাট ঠাট
but quality is same.
মশার জন্মের মশার জন্মের মশার
So,
জন্মের
this length of the vowel is increases, I just only repeating the single period. So, steady state vowel, I can change the steady state vowel length by repeating the same period. So, if you see the example, I can show you, this is the less steady state vowels are very small. If you see it,
রাজা মহানন্দ রাজধানীতে তৈরি করেছিল শিব মন্দির ও বৈষ্ণবদের মন্দির।
steady state vowel duration are very less. If I play this,
রাজা মহানন্দ
only the steady state vowel portion are lengthened.
শিব মন্দির ও বৈষ্ণবদের মন্দির।
Okay. So, this technique is used in Bengali TTS to produce that any. So, this TTS engine can itself take any word you can give, it can pronounce with the same clarity. But the main problem is that prosody is not there, prosody is not there. So, prosody has to be incorporated. So, that I will discuss later on. So, this is Bangla TTS, we call ES-NOLA, epoch synchronous overlap add method, and this is the block diagram of the whole TTS. If this is the block diagram of the whole TTS engine, and this is the rule we have written down, then we generate this dictionary is created. So, we recorded how the dictionary signal dictionary is created, we recorded all the consonant with vowels in a nonsense words. So, how the dictionary is created, I can told you that the problem is that if it is ko and then it is a. So, I recorded ka 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 4-5 times and I take the most appropriate one, middle one, and then I can cut the occlusion period plus bast is my ko. Then from the bast end of the bast to steady state vowel is my ko to vowel transition. Then I do not require the steady state vowel because I can repeat the last period many times, how many I required, and then there is a vowel to consonant transition. So, it is there will be a vowel and there will be a consonant transition. So, VC portion will be there, and then again there will be the consonant which is occlusion plus bast. If it is stop consonant, if it is vocalic consonant, same up to beginning of the VOT, and from the beginning of the VOT to steady state is called consonant to vowel transition. So, ka 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 kha 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 kha, all consonant with vowel combination recorded and cut to create the dictionary, and once the dictionary is created, any text will come, pass to the rule, and it can generate that. Okay. So, this is used in ES-NOLA synthesis. Then there is a unit selection method will come, because if I see the all diphone based TTS and all that part name based TTS has some problem in natural prosody, because prosody is not there. I have to model that prosody, but modeling of the prosody is not that is simple. So, they said instead of selecting the diphone, can I select a larger unit, because today memory does not have any problem, the computer memory become very easy, computational power also is there. So, I can say I recorded large amount of speech data from a single voice, because if it is mixed, then male female will be mixed. So, from a single voice I recorded large amount of speech data. Then once the input text is come, I search on that large amount of, this is the label speech data. So, this resource is large amount of label speech data is available. Once the label speech data is available, whatever the input text will come, I can search on the label speech data and find out the best possible match part of that corresponding to input text, and I can produce, that is my synthesized speech. So, that is called unit selection based speech synthesis technique. So, if it is unit selection, so if you see, only problem is the unit selection is that how do I select the unit? So, given a big database is there, for each segment that we want to synthesize, find the unit in the database that is the best to synthesize this target segment. How the best is measured? Depending on the target cost. Closest match to the target description in term of phonetic context, F0, trace, phase position, and joining cost is that best to join the neighborhood unit. So, when I join it, the end of a segment and another end of a segment, how they are joining good, and how this whole segment and these segments are good to join together in term of closest matched target description in term of phonetic context, F0, trace, phase position. So, in unit selection, prosody is inbuilt. I cannot modify that, I am not used to modify that synthesized speech according to the language. So, the prosody which is come in unit selection method, which is available in the database. If the text which is given, if it is whole text is available in the same context, then I will get the best prosodic match sentences. But suppose that input text does not have any instant on this database, only some part diphones are there in here and there, then if I club together, then I cannot minimize the target cost, and the prosody which will come, it is not come depending on the language structures, it will come within the available label data prosodic structure. So, prosody is driven by the data, but if the data is big, then my synthesized output will be good. If the data is less, the synthesized output quality will be not that good. So, target cost and joining cost, based on this two cost function, we select the. So, Carnegie Mellon University, that is the unit selection TTS are there, festival engine, you have heard about that festival engine. So, that is nothing but a unit selection based TTS system. Okay. I have not details described the target cost, it is available in the slide, you can go through it. Then there is another TTS is come, HMM based synthesis. This is HMM based synthesis. We have developed for Bangla also HMM based synthesis. So, it is two type, one is called parametric. If I use the vocoder, then it is parametric synthesis, because here what you do, speech database is there, we extract the excitation parameter. So, if you see the speech signal consists of two parts, one is called segmental, suprasegmental, or I can say it consists of two parts, one is called excitation parameters, another is called spectral parameter, or you can say if I have a vocal track is excited by a vocal cord. So, I can say excitation parameter and vocal track parameter. So, this is called spectral parameter and this is called excitation parameter. So, we have separate from a large speech database, we have separate the excitation, we have the excitation parameter and also we have a spectral parameters. Based on these two parameters, we developed HMM parameter estimation technique. Okay. Now, once the text is come input text. So, text analysis is done, contextual labeling is done, then depending on that text we have estimate the parameter, which segmental parameter is best match for that input text and which excitation parameter has the best match with the input text. Once I get the excitation parameter and spectral parameter, then we can use the synthesized filter or vocoder to generate the speech. So, that is HMM based speech synthesis technique, which is used in which is named as HTS, hidden Markov toolkit based speech synthesis technique. Okay. So, next class I will discuss about that ASR, some portion of the ASR, and then we talk about that accent conversion, that things, and the last week is the prosody. Okay. Thank you.